Hello, viewers. In this tutorial, we'll be looking at a quick review of P5, which is algebraic expression. So we'll be discussing about polynomials. So we'll look at the operation of polynomials. So that's addition, subtraction, and multiplication only. Then we'll take a look at some special product formula. Then finally, we'll look at some exercises. So let's talk about an algebraic expression. Now, before we about this one, we need to know, let's say we have a variable. Let's say we have a variable. So a variable is any what? Is any letter, say maybe X, Y, it could even be Z. It could be any letter to represent what? Represent, let's say, a real number. Let's keep it simple now. Now, if you take this variable and let's say you add, let's say another real number, let's say 5, this becomes an expression. It becomes an algebraic expression. Or let's say you even take the root of what? Of X, and you subtract maybe 1. This is also an algebraic expression. So for you to have an algebraic expression, you just need a variable. Then you could add any real number, or you can just write even just maybe the variable itself is an algebraic expression. But here this variable represents in a real number. We can have maybe like y square minus what? Minus 3 over y plus 3. So all of these are algebraic expression, and we can form many more. So you can see here we have an operation, we have addition, we have subtraction, and here we have division. You can even multiply, let's say, x times y times z. This is also an algebraic expression. But today our focus is more on a particular type of algebraic expression, which we call polynomials. And what are polynomials? So a polynomial in a variable, because you need a variable, just like we discussed here. For you to have an expression, you need a variable. So here, let's say we have a polynomial in a variable. Let's say our variable is x. Is an expression. So when we say it's an expression here, we mean it's an algebraic expression of the form say, let's say px equals to an xn plus an minus 1 xn minus 1 plus dash dash. Then we can come close. Let's say we can say plus a1x, then finally a0. Now let's define what we have here. Here, where an, or we can start from a0, a1, a2, up to an are real numbers. And what is n? N is a non-negative integer. Okay. So if you look at this, what we're saying is that you can see the number an, these are the number behind the variables. The an's, a0, a1 up to an, they have to be what? They have to be real numbers. So real numbers, it means they could be rational, they could be irrational, there could be whole numbers, there could be integers, there could be natural numbers. So all the numbers that we discussed before under the category of real numbers. So the a's can be any of those numbers. And in general, we have a name for them. Um, Take notes. We say the A0, A1 up to AN are called what? Coefficients. Okay. So for example here, you see AN minus 1 is the coefficient of xn minus 1. And A0 is the coefficient of x to power 0, because here you have like x to power 0 here. Okay. Now, let's discuss some few things here. Now, if your an is not equals to what? 0. If an is not equals to 0, example in this case, if this an is not equals to 0, then we say that the polynomial p of x has degree, and that degree is what? Is n. So if your an here, which is this coefficient, is not equals to 0, then it means the highest power in the polynomial will be this n. So that n will be the degree of the polynomial. All right. So it's very important for us to know also some terms. This an, which becomes the what? Which is the coefficient here of x to power n, that is if an is not equals to 0, that an has a special name. It's called the leading coefficient. Okay. And one more thing is this, is that a0, and what is a0? A0, you can see, is the coefficient of what? Of x. You can see that here the powers of x are reducing. Here, the second to the last term, the power of x is 1. The last term here, you can say the power of x is 0. So a0, which is the coefficient, okay, let me say a0 is the coefficient of what? X to power 0 is called the constant term. Very important. So this, you see, the leading coefficients and the constant term. Let's take note of them. All right. So now, if you look at this polynomial has many terms. So each of this term, or each of this monomial, for example, this one, you have one term here, you have two terms here, you have three terms continuously. So we'll be looking at polynomials. Some polynomials have only one term, some have two terms, some have three terms. And so that is what we will discuss next. So let me just let's just take some examples here. Now, let's look at this. This is 2x to power 3. Just a quick table here. And let's say this is type. And let's say degree. And let's say what is the leading term. And finally, we'll look at the constant term. Okay. So drop this here. So 2x to power 3. If you look at 2x to power 3, this is a polynomial, but it has a special name because it has only one term. So because it has only one term, the special name is called monomial. So anytime you see a polynomial that has only one term, it has a special name called monomial. And here, why is this a polynomial? If you look at it, the highest power of x here is what? Is 3. And 3 is what? Is an integer. So it means this is satisfied. It satisfies our definition of being a polynomial because the n has to be a non-negative integer. So n is 3, is a non-negative integer. And you can see the power is also, this is the only power. So we don't have to worry. And the coefficient, here it has only one coefficient, which you can see. And this coefficient is any is a real number. So this qualifies to be called in this category. So now what is the degree? Just like we said, the degree is the highest power of what? The highest power of the variable. The highest power of the variable here is what? Is 3. So the degree is simply 3. And what is the leading, let me say the leading coefficient? So the leading coefficient is just the number behind the term with the highest power. So the leading coefficient is 2. And the constant term in this case, remember the constant term, which is the a0, is the coefficient of x0. But what is x0 here? As you can see this, if you want to write this, you can write this polynomial as 0x to power 2 plus what? 0x to power what? 1, then plus what? 0x to power 0. So you see, the coefficient of x to power 0 is what? Is 0. So it means the constant term is simply 0. Next one is this one. This is 4x to power 5. This is what we call binomial because we have only two terms. So this is called binomial. And what is the degree? The highest power here is of x is 1. What is the leading coefficient? The leading coefficient is this number behind the variable with the highest power. So it's 4. The constant term is the coefficient of x to power 0 because this is like x to power 0. So this is our constant term. So the constant term, it's 5. Then let me just take one final one, which is 6x to power 4 plus 3x to power 2 minus 2x plus 1. Here, you can see in this case, we have how many terms? 1, 2, 3, 4. So since we have 4 terms, all we need to call it. Okay, I think before we take this one, let's take one more here. Let's leave this as D. So let's add a C here, which is minus x squared plus 3x minus 6. So here you see that it has 3 terms, so we can call it trinomial. And the degree here is 2. The leading coefficient is minus 1. And the constant term is minus 6. Look at the constant term is minus 6. You have to go with the negative as well. Now, for the D, you can see it has 4 terms. So since the term is more than 3, the special name is just the polynomial. And the degree is the highest power, which is 4. The leading coefficient is the number behind the variable with the highest power, which is 6. And we have the constant term, which is 1. So next we'll look at this special product. We'll talk about the operation later, operation on polynomials. Now let's talk about special product formula. It said if a and b are real numbers or algebraic expression, then we have this to be true. This is if you have a plus b times a minus b, this is a squared minus b squared, difference of 2 squares. And a plus b all square, this is a squared plus 2ab plus b squared. Now, if you look at these 4 and 5 has to do with what? The power 3. And here we have a cube. So this is a cube here. Then you see the coefficient here, which here is 3, here is 3. Here the coefficient is 1, here is also 1. So the difference between 4 and 5 is just that the signs are alternating. Here you have plus, from plus to minus, to plus to minus. So take note of this alternation in sign. Now, how do we get this coefficient? Let me just remind you quickly with what we call the Pascal triangle. So the Pascal triangle, we start with 1, then here you put 1 here, we end here with 1. Then you go to the third line, you start with 1 as well. Then you add 1 plus 1, which is 2. Then you end it up with 1. You go down, you start with 1 again. 1 plus 2 is 3. 2 plus 1 is 3. Then you finish it 1. If you want to go to the fourth level, you have 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is also 4. Then you close it with also 1. Is that okay? So what does that mean? It means that we have what? We have this to be to power a. This is like a to power 0. This is to power 1. And this is to power 2. And this is to power 3. And this is to power 4. So this is where we get the coefficients from. So like in the case of power 3, you see the coefficients are 1, 3, 3, 1. So 1, 3, 3, 1. If you want to power 4, the coefficient will be 1, 4, 6, 4, and 1. Okay. Now let's answer a few questions here. Okay. Now we have A to E expressions. From A to E, we want to check which one is a polynomial. So if you look at the first one you say, this is a rational function. Remember, a rational function, it's any function where the numerator is a polynomial and the denominator is a polynomial as well. But a rational function is not a polynomial function. Another thing you can simply use here, and if you remember, since this is a review, we know that what? The domain of a polynomial, we've seen the domain of polynomials before. The domain of polynomial is what? Is the whole R, right? Minus infinity to infinity. So easily you can see that this function is not a polynomial because the domain of this function, you have to remove what? X equals to 3. Because x equals to 3 makes the denominator 0. So this cannot be a polynomial. Now, if you go to B, B is a polynomial because it satisfies the condition. If you look at all the coefficients, pi, 4, 1 over 3, they are all what? They are all real numbers. And you can see the power of x. You see the x here is to power 3, x here is to power 2. The power x here is to power 1. X here is to power 0. So all the x's, all the powers are integers. So this is a polynomial. Now, C is not a polynomial. Clearly, you can see that this is what? X squared plus 6x to power what? Half. So you see the power here is non-negative. You can also use the idea of domain. You can see the domain of this is not the whole R. Since you have an even root, the domain will be what makes the inside, what makes what? X squared plus 6x to be greater or equals to 0. That will give you the domain, which is not the whole R. So with that, you can also eliminate C. Now, if you look at D, we also saw that we can write this as x over x when x is greater or equals to 0, and minus x over x when x is less than 0. Simply, we just use the definition of what? Absolute value, right? And this is just going to be 1 if x is greater or equals to 0, minus 1 if x is less than 0. Is that okay? So so clearly, anytime you see an absolute value, it cannot be a what? It cannot be a polynomial. Now, but let's use this. you can graph this one easily. What is the graph of this? This is 1 when x is positive or greater than 0, you have 1, and you have minus 1 when x is less than what? 0. Now, if you look at this one, this is a graph, right? And this graph has a hole, yes or no? You can see it has a hole here, and it's not continuous. So you can see that. Don't forget that the graph of polynomial, this is also an additional hint. Graph of polynomial is what? Is smooth. We also saw this before. And what? Continuous, right? Okay. Now, so you have a lot of information. You don't have to just depend on the definition. You can use the fact that the graph has to be smooth and continuous. You can use the fact that the domain has to be what? The domain of polynomial has to be all real numbers. So with that, now you can eliminate this. You can use the fact that this graph is not, it has a hole, so it cannot be a polynomial. Now, if you look at this, this is clearly easy. It cannot be a polynomial because you have x to power what? 1 over 3. So we know that the powers, if you use the definition, what did we say about the n's? If you have n minus 1, x minus, this n has to be what? Positive, non-negative integer, right? Non-negative integer. It means it could be 0, it could be positive. Okay, so we have eliminated everything except b, which is a polynomial. Now, for question number two is of operation, because here we have f, we have g. We want to find f of x minus twice g of x. So what is f of x? Is 3x to the power 2 minus 4x plus 7 minus 2 times g of x is 2x cubed minus 4x squared minus 6x plus 5. So we can finish the multiplication first. Let's leave these two outside and put a bracket. This is 2 times this to give us 4x cubed minus 8x squared minus what? 12x, then plus 10. And then we still have this one here. So now let's perform subtraction. Let's subtract these two polynomials. So how do we subtract? For multiplication, just multiply. If you're multiplying by a scalar, just multiplying each term by that scalar. So here, now we want to subtract. When I say scalar, I mean constant, right? So to subtract here, you need to deal with the coefficient. Here you can see this is x to the power 3. But in the first term, there is no x to the power 3. So we can just add 0x to the power 3 here, which is still the same. It means that x to the power 3, the coefficient of x to the power 3 is 0. So since I'm subtracting here, what do we do? What we can do is to subtract the what? The coefficient. So this is 0, 0 here. So I have 0 minus what? Minus 4, right? Then have x to the power 3. Then I need to deal with x to the power 2. This is the coefficient, 3 and what? And minus 8. So what we will have, we're going to have 3 minus 8 all x squared. Why do we have this minus? Because it's coming from this one. Then now we need to deal with the x here. So this will be plus. For the x, the coefficient of x here is minus 4. So I have minus 4. And here also I have, this minus is here. So I have minus 12, all x. Then finally we have the constant term. The constant term is going to be 7. So we have 7, then minus 10. So this will just become minus 4x to the power 3 plus 11x squared, because minus minus becomes plus. And this will become plus as well. This is minus 4 plus 12 will give us 8x. Then finally 7 minus 10, which is minus 3. So we're done. So here we've done both subtraction and multiplication when you have a constant multiplying g here. Now, number three. Number three, we want to find the degree here. So to find the degree, we need degree simply means what the highest power of the variable in the polynomial. So here we can use what we saw earlier, one of the special product formula. So it means we can use this expansion, right? And we can also use the expansion for a plus b all square. But we don't really need to go all of that because we are not looking for the polynomial itself. We are not looking for the expression. We are looking for the what? The degree of the polynomial. Now, when you have this polynomial with two terms, the highest power of the variable will come from the first term. So it will come from x squared y all to power 3. So the highest power from the second polynomial, this one, will come from this first term here, which is 2x to power what? To power 2. So with this, we are done because we are looking for the highest degree. And since we are multiplying these two polynomials, this one alone will give us what? X to power 3, y to power 6. Then we have to multiply by this one, which will give us 4x to power 2, right? And now let's do this multiplication together. This will just give us 4x to power, this is 3, power 3, power 2. So you have x to power 5 and y to power 6. Now, this will be the leading term of this expansion. So you don't have to go and expand everything because you are looking for the degree. So you just need to get what will be the biggest, the leading term from the first polynomial and what will be the leading term from the second polynomial here. So here, since we are looking for the degree, this is a polynomial in two variables. So the degree is just going to be 5 plus 6. So you add the powers, the two variables. If you have three variables, add the powers. So this will be 11. So this is the answer. Now, number 4, it said if m is the leading coefficient and n is the coefficient of x squared in the polynomial. So we want to find what is m minus n. So for this one, what we can do, maybe we can just do it fully just to make use of we can make use of the special product formula, right? So let's see. Let's start with this first one, which is 2x minus 3 cubed. Now, how do you do this? If you memorize the formula, it's fine. This is, remember, we're going to use a minus b all cube, which is what? A cube. Since this is minus, so this would be minus what? 3a square b. Then you have plus what? 3ab square, then minus what? Minus b cube. So in this case, what we're going to see, I want you to see this as the whole of a, and you want to see this as the whole of b. So this is going to be 2x to power what? 3 minus 3 times a. A is still 2x, so we're taking a, and so you take a as 2x and take b as 3, not as minus 3. Don't worry about the minus. The minus is already factored in the formula. So this will be squared. Then here we'll put 3, right? Then from the formula you have minus, then you have plus 3. Let me remove this now. Then the power of a will reduce. The power of 3 will be squared. Then finally, then you have to be minus what's b cubed, right? Which is just going to be 3 to power 3. So let's remove all of this. Now, what is this one? This is going to give us 8 what? This will give us 8x cubed minus. Now here, you see this is 3 times 3, which is 9, right? But this is 2 square, so 2 square is 4. So you have 4 times 9, which would give us what? 36x squared. Then plus, here it is 3 squared. This is 3 squared is 9, right? So we have 9 times 3, which is 27, times 2. This is 54x. Then minus 3 cubed, which is 27. So this expression is for 2x minus 3 all to power 3. So let's keep this first. Okay, then let's do the second one, which is 3x minus 2 all square. Now you are dealing with square, and we also saw in one of the formulas that if you have a minus b square, it's nothing but a square minus 2ab plus what? B square. So this is simply going to be 3x all square minus 2 times 3x times 2, right? Then plus what? Plus 2 square. Now this is 9x square minus 12x plus what? Plus 4. Is that okay? So this is what we have. 3x minus 2 squared is equals to this. Now, so if we have 2x minus 3 cubed minus 3x minus 2 squared, it's equals to, now we have to what? Subtract, because we have the two terms. So this is just going to be 8x cubed minus 36x squared plus 54x minus 27. Then subtract it from 9x squared. We subtract this from it. Okay. Now, if we look at this, what do we get? This will just be 8x what? Cube, because here there is nothing to do with x cube coming from here. Is it? Now, for the what? For the x squared, this is 30 minus 36 minus 9. So this will give us minus 45x squared. And what do we have here? Here we have 54. The coefficient of x is 54. Here the coefficient is 12 with a minus, but there is a minus here. So this is 54 minus minus 12, which will give us 66x, right? And now we have minus 27, and also the constant term here is 4. So you have minus 27 minus 4. So this will give us minus 31. So this is our expression for this polynomial here, or now this is it. So to answer the question now, we want to find the leading coefficient of n, the leading coefficient, which is what? Which is m. So it means that m is going to be 8, right? And what is n? N is the coefficient. N is the coefficient of x squared. So n is going to be minus 45. And so therefore, if you do m minus n, we will have 8 minus 45. And this should give us what? 53. So we have C to be the answer. So this is just a short, a quick review, and just few exercises as well. I hope this tutorial is a good review of chapter P5. And I hope you enjoyed. Thank you for watching.